Now today we'll be getting into networking, right? So what are the major elements of networking that are basically should be used within AWS Cloud? So we'll walk through some of the key elements of networking, for example, VPC, security groups, ACL, and stuff like that. And if time permits, what I'm going to do at the end of the session, I'm going to go ahead and log into or maybe along the way, I'll log into the AWS account and show you how those subnets are created, how those VPCs are created. It gives you a little bit flavor of, a touch of how these networking pieces are built or set up on AWS. So with having said that, let's go ahead and jump right into it. So the very first element of networking within AWS is a VPC. What is a VPC? VPC is a virtual private cloud. And you can think of VPC as a data center within AWS Cloud, right? And it's a private, right? It's a private virtual cloud where you can host behind the think of as a firewall, all of your servers, your EC2 instances, your databases, and whatever you may have behind that VPC, the virtual private cloud, right? This is the layer which basically you can configure who should have access to and who should be denied access, right? You can also define your subnet, which it could be a public subnet or a private subnet inside of that VPC. It allows you to give a granular level of accessibility. So, for example, if you want your QA not to access some of these servers, then you can define a subnet within the VPC and maybe disallows your QA team members to access that. You may have some production environment that is off limit to the developers, for example. You define those rules and regulations within those VPC and the other component, which are security groups, which we'll talk a little bit more on that in a second. You can also create a hybrid solution between on-premise and AWS Cloud. So you can define a VPC, which can connect and expand between your on-premise and the environment within AWS. Then we'll talk about the CIDR, which is the Cidr address, which basically is the actual IP address range that you assign to your subnets, right? So, for example, within a VPC, you can say, okay, my private subnet would start from 10.0.0.1, and it's going to go to, and it's going to have /, let's say 24. So it may have, 32 minus 24, let's say 8, 2 to the power 8. So you would have 256 addresses, for example. Or you can have just one IP addresses. You may say 10.0.0.1 / 32. So the IP address range would be 2 to the power 32 minus 32, because you have put / 32. That would be 0, and 2 to the 0 is basically 1. So it's only one IP address you will get from that subnet. Again, don't worry about it. I'll walk you through when I'm setting up the IP address and give you some examples of how to set up the Cidr address. Along the way, guys, if you do have any question, feel free. You can post the questions, and Shane will let me know the question. I'll try to answer as we move along. Okay, so accessing Amazon VPC is you do have an AWS management console where you can actually come in and use the console to access and create the VPCs. You can also use the CLI, the command line interface, which basically allows you to go into that command line interface and type in all the commands. You can also use SDK. So if you're a coder and if you want, or your a team or your organization wants to access some of the environment EC2 instances via code, you have AWS SDKs that allows you to access those assets in the AWS environment using the software development kit SDKs. You can also use the query APIs in order to access the VPCs. Pricing for VPC, there's no charge. This is $0. You can create VPCs. However, there is a quota on VPC, 5 Amazon VPC per AWS accounts per region. So if you want to create VPCs in, let's say, US East region, you have 5 VPCs that you can create. Now, why would you create more than one VPC? You can think of VPCs again where you can bifurcate, you can actually divide your environment within those VPCs. For example, you may say, okay, I'm going to have a VPC environment for my development work, another VPC environment for my QA work, and one would be pure production, right? In my dev environment of VPC, I would have 5 instances of EC2s, or 2 EC2 instances. In QA, I would have only 2 or 3 EC2s instances, and only QA team members can access the VPC on the QA VPC. On development, only the development team can access. Now, in the previous session, we talked about the accessibility, where you can define the roles and permissions, where you can say, okay, the development team can access these resources versus these resources can be accessed. These resources can access QA versus these resources can access production. So, defining those roles and permissions using the IAM roles, right? And then also then dividing your VPCs based on the nature of the work would help you segregate the environments within based on the needs, right? So this way you are not really exposing every single environment to every single resource. I hope that makes sense, right? So the example, like I suggested, would be an environment for my development team where people can come in and do the development and nobody else have access to it, versus my QA environment where my QA have access just for QA purposes, and then production where nobody has access except the production team members. Okay. What are the components of VPC? So the major components of VPC, number one is a Cidr address, right? So that is the address range block that you want to say, okay, my VPC can be accessed by this IP address range. Then within that address range, you can define your subnets. So a subnet could be a private subnet versus a public subnet. The difference between the private versus public subnet is that a public subnet can be accessed, or it can actually go out, and it can be accessed from outside, like your web server that is hosting your web application. It needs to be on a public subnet. A private subnet would, on the other hand, would be something that the outside world doesn't have access to it, and that would be something that where you would actually put your database, for example, right? So if you have, or some other processing servers that you want to actually use for your web application that you don't want to expose to outside world, you would actually put it behind your private subnet. So an example like I gave was the database, right? So if your application is accessing a database, you don't want to expose that database to the world. That's a bad design, bad architecture. However, your application should be the only thing that needs to access your database whenever the application needs to talk to the database for CRUD operations. So you want to make sure that all of your servers that are not needed for the public exposure, put them on behind the private subnet. Anything that needs to be accessed by the public needs to be put on this public subnet. And again, we'll walk through the example how to actually create that public and private subnet. The other thing is a routing table, which basically any IP address that is coming in from the outside or the internet inside, it actually routed to the route table. So you define the routing within the route table. Then you have the DHCP, where you define the dynamic host configuration settings. Security group is another important one, right? So security group is whenever it's something, whenever an IP address is trying to access an EC2 instance, for example, the security group comes into play, right? It says, okay, is this IP address allowed, right, in order to access this EC2 or not, right? If it is not in that security group IP list, then it would actually reject it. Okay. The other thing right below is the network access control list, which is ACL, which is where you define what is not allowed. Okay. So if you want to, for example, block an IP address which is constantly hitting your servers and it's probably doing phishing and some SQL injection and whatnot is coming from a specific IP address, you would actually put it in deny list of ACL, versus security group where you define, okay, this TCP control or TCP IP protocol is allowed for this IP address range. The ping is allowed for this IP address range. The database access port is allowed for this IP address range. SSL versus SSH, all that stuff, what is allowed from that specific IP address range, you would put it under security group. What needs to be denied, you would put it under the ACL list. I hope that is clear for you guys. Now, these are the very important components, right? The other optional components are Internet Gateway, Elastic IP address, endpoints, peering, and network address translation, NAT instance, and virtual private gateway. Now, Internet Gateway is basically is used whenever you have a private subnet and you want to allow your private subnet, let's say for some installation on an EC2 instance which is sitting behind your private subnet. So you have to define a route outside of your private subnet for that EC2 instance to maybe have some installation of MySQL or whatever. So you would actually put a internet gateway so that your EC2 instance, which is your behind private subnet, is allowed to get out of the private subnet and access the internet for whatever installation or whatever reason it is. The other thing is Elastic IP address. So if you want to assign a specific IP address that stays with the machine, you can also define EIP, Elastic IP address. Let's skip the endpoints. Peering is basically if you want to define two VPC to talk to each other, you can define the VPC pairing, right? So there might be instances where your dev environment and QA environment need to talk. So what you need to do is you pair your VPCs and by using VPC pairing, and then allow the two to talk to each other. Net instance and net gateways, again, they are kind of similar concepts where you can have an instance where you install an internet routing out using either a net instance, which is not really recommended, or I'd say it's an older technology. Then you have the net gateways, but both can be associated in order to get out of the VPC or the private subnet. You can install that net instance or net gateways. Virtual private gateway, again, this is just a gateway for VPN, or if you want to get the connectivity from your on-premise to AWS instance, and if you want to establish a connectivity between the two, you may want to define a VPN, a VPG, or customer gateway. What this does is basically allows the connectivity between your on-premise and AWS. A good example would be where there are certain servers that are sitting on your EC2 instance that doesn't need to be exposed outside, but your employees need to have access to it, and it's that server sitting in AWS behind your VPC. But the resources are sitting at an office, remote office, and they want to access that server. How do you do that? You can define a customer gateway, you can define a VPN or virtual private gateway, and that makes a connectivity between the offsite office and also the AWS VPC. And that connectivity basically is secure if you're using a VPN, for example, using the tunneling. And that basically allows the connectivity to be established between the offsite office space and also AWS VPC. So again, depends on the need. There are cases where the offsite or remote office location need access to the instances on the VPC, and that is the best way to actually establish that. Okay, these are the optional guys, and then these are the majors. So without this, you can't really have a proper VPC connectivity. Some of these things we'll talk about it, where whenever you set a EC2 instance, by default a VPC is set for you, the routing table default is set for you, dynamic DHCP is set for you, a security group is already set for you as a default, ACL is set for you. Some of these things are already set up whenever you are setting up an EC2 instance within the AWS environment. Okay, let's talk about the examples within the subnet and VPC. So this is your AWS environment holistically, right? If you look at it, then you have within that AWS environment, you create a VPC, right? Virtual private cloud, right? And so once you create that, then you have those subnets, right? So this is a subnet 1 and this is a subnet 2, right? And these subnets you can define it as a private or public, right? And you define these Cidr addresses, right? So a Cidr address would be something like this, right? So a VPC is defined 10.0.0.0/16, right? So what does that mean? So let me just jump over to the calculator real quick, and so that I can show you that. Okay. Can you see the calculator, Shane? Can you confirm?
Yes.
Okay, so it was defined as 16, 10.0.0.0/16, right? So the way you find out how many addresses you have in that Cidr address block, you take 32 minus 16, right? And actually, let me just view. And then basically you take 2 to the power of 16. 65,536. So this is the address range you would get if you define your VPC to be 10.0.0.0 or .1/16. So you'll get 65,000. Now, if you want to limit it to, for example, a less block of IP addresses, like again, let's say you say 10.0.0.0.1/24. So the way you find out how many addresses you will get or how many IP addresses will be assigned or can be assigned in that VPC would be 32 minus 24. So it's 8. And then you take 2 to the power 8. So you get 256 IPs that can be defined in that VPC. Okay, that's how you actually find out what are the IP address range you will actually get when you define the VPC address range. Okay. All right, let me just go back here. Okay, so in this case, for example, this VPC is defined at 10.0.0.0/16, which means, again, 65,000 plus address range within this entire VPC. Okay, now here you see there's a subnet 1, subnet 2. So what's happening is, like I said, the IP address range was from, excuse me, 10.0.0.0/16, which gives you 65,000 plus IP address range. Within that IP address range, you can define your subnets, private subnet, public subnet, whatever you want to define it. And then you can further say, okay, this subnet would have this IP address range and the other subnet would have this IP address range, right? You can have private, public subnets within that VPC. So in this example, for example, is saying, I'm going to start with 10.0.0/17. So again, you will take 32 minus 17, and whatever that number is, you take 2 to the power of that number, and that is the IP address range for this subnet 1. This IP address range would start 10.0.128.0/17, but note that it is starting from 128, right? So you will take that, and then you will start from 128, and then 0, it will be actually incrementing the number from here, 0, 1, 2, 3, 4, 5, and so on and so forth, taking all the ways up to 32 minus 17, whatever that number is, to the power of that, and that would give you that range for subnet 2. Okay. So this is how you actually get the IP address range using the Cidr block, right? The way that it happens is basically it gives you a main routing table, and this is where it would define the address range. So now, which leads me to the routing table discussion, right? So once you have defined your VPC, you define your subnets, saying, okay, well, these are my subnets. The routing table makes an entry saying, okay, whenever there's a call coming from outside or internal AWS, how do I translate that into which subnet I need to go, which IP machine that I need to go and hit? This routing table is basically mapped, and it's created automatically, right? And it says, okay, all of this IP range, 10.0.0.0/16, is local IP address range, which is defined over here. So this is the VPC that I'm going to be using whenever the request comes in. So request comes in, main routing table gets hit. Main routing table says, okay, where do I go? It says, okay, well, this range is defined local to this VPC, and it basically tries to translate, okay, this is the IP range. I'm going to go in and I'm going to probably hit this machine on this IP address. So this routing table is basically used for that. Now, if you have multiple subnet, for example, in this case, you have subnet 1, 2, and subnet 3. So it basically defines that 10.0.0.0. Now, notice here, this one is defined at 10.2.0. So basically, I'm saying 10.20.0.4/16 is also locally associated with this VPC. You don't have to do anything here. Main routing table is automatically created for you. It basically, you can also create it, but when you create a default one, it basically creates it for you, and it knows the exact IP address string that it needs to associate with. Okay. All right, so this is where, again, another example. So for example, these are the ranges 10.0, 5, and 6, and 7. And these are all mapped. For example, this is your main routing table. This is by default created, right? And this is if you want to have an externally going out internet gateway that is associated with a specific subnet. You can also define that, and here you would create a routing table, and you would define what are the IP address range that needs to be actually associated with this subnet. So 0.000.0/0. Every traffic that is coming in with this IP address range would be actually going into this internet gateway to this subnet. So this is a custom IP, you can address it. These are the elastic IP address. So if you want to associate specific IP addresses to specific machines, you can get those elastic IP addresses and tie them here. For example, you can say this EIP 198.50.100.1, this is my IP address, is going to be associated with this local IP address, subnet IP address, which is 10.0.05. And then this one, 198.50.100.2 is associated with 6, and so on and so forth. So you can map or associate elastic IP address that you can get, which means that whenever your EC2 instance is recycled, that elastic IP address would be still with that's associated with the same machine. You have to make sure that if you don't use those elastic IP address, you release them. And I'll show you how to actually get an elastic IP address, because you will get charged. And again, for your production environment, you may want to probably get some fixed elastic IP addresses. But if you're using, QA, and you really don't care if you get a new IP address, you can just leave it as is and use a dynamic IP address. Okay. If you look at the holistic diagram over here, so again, this is AWS environment. This is your VPC. Within VPC range, you have 10.0.0.1/16, 65,000 range defined. You can define a subnet where you say, okay, 10.0.10.24, and this one is 10.0.0.24. This is all associated with the router, because everything from the internet first comes in, and let's say that there's the internet gateway defined, and that comes into the routing table, right? Routing table basically says, okay, where do I go? And then let's say if you have an IP address, which is EIP, it says, I have to hit 198.50.100.1 from the internet. So internet gateway allows the traffic. It goes to the routing table. Routing table says, okay, there's the machine right here. And it translates that 198.51.100.1 to 10.0.5, because that is the main IP address that was defined at the 10.0.1 level. Sorry, give me a second. Here. So the internet, this green line shows you these are the IP addresses which are being accessed from outside, right? Obviously 10.0 range is an internal subnet IP address, not everybody would know. That's why you need an external EIP, which is defined over here, 198.50.100.1, which basically is used by the internet gateway to forward to the routing table, and then routing table says, okay, this is the machine that they want to access to. Okay, so these are the components, right? So you have the VPC, you have the subnets, you have your router, which basically has the routing table and determines that, and then you have internet gateway, which is basically exposing all the traffic to and fro from the internet. Okay. Okay, what is a Cidr address, right? A Cidr notation is a compact representation of IP address and it's associated with routing prefix. The notation is constructed from an IP address with a forwarding slash, right, and a decimal point. For example, I've given you this as an example, 10.10.0.0/16, right? And this is the formula I was talking about, right? So it would give 32 minus, in this case, 192.168.100.022 would be 32 minus 22, right? 32 is because of the 32-bit, because everything is 8-bit, right? So that's why you see, and the range is you have 4 bytes. IP address range, so that's why it has 8 bits in each byte. So you take 4 times 8 is 32 bits. So you take 32 minus 22, which is defined right here by /. This would give you 10, and then again in the decimal notation, you would take 2 to the power 10, would give you 1,024 IP addresses. So then it starts putting it 192.168.100.0 to 192.168.103 to 255, because obviously if you take an octet, which is a 8 bits long a byte, then you can have maximum of 8 bits there, which can be turned on, and that 8 bits, it would give you a 255 range, right, a decimal range. So that's why the maximum value in each octet or each decimal number would be 255, and as this number is 1024 addresses, that's why it says, okay, you can go from 192.168.100 to 192.168.103 to 255. Okay, so this is how you define how many IP addresses you can have within it, and the formula that you use is 32 bits, again because of the 4 decimal or 4 bytes, and then 8 bits in each octet, and multiply that by 4, so that would give you 32. And then whenever you put /22, this is how many address ranges you are asking. So 32 minus 22 is 10. 2 to the power 10 in decimal in binary would give you 1024. IP6, this is again an advanced topic. IP4, we are soon running out of IP address range, so they wanted to actually go with the next level of version of IP addresses. So IP6 is coming out, which would actually give you a lot more address space than IP4. Okay. All right, let's talk about what is a subnet. Subnet, again, I touched briefly, is a segment of an Amazon VPC IP address range, right? Used for launching EC2 instance, RDS, and other AWS ranges. For example, 10.0.1.024 or 10.02, which is in green, are 2 subnets where instances can be launched. Right, the first 5 IP addresses are basically reserved by AWS, so you can't use them. 10.0.0.0.0, 1, 2, and 3, and I think 4, if I remember correctly, is reserved by future usage. 0 is for routing table, and 1 and 2 and 3 are used for other reasons for AWS. You cannot use those first 5 IP addresses in that subnet domain. So you can always start from 5, 6, and onwards. Subnets can be spanned across multiple AZ, but you can have multiple subnet. Subnet cannot be spanned across AZ, but you can have multiple subnet in a single AZ. So I think in my previous example, I showed you right here. So this is actually multiple subnet defined, right, in a same availability zone. Okay. All right. What is a routing table? Routing table is a logical construct within VPC that contains a set of rules called routes applicated to subnet. Again, in my example, remember when a traffic from the internet gateway is coming in and you have the IP address of 192.168.1.0, for example, which IP address should I translate it to? This is where the routing table comes in. Routing table says, okay, well, this IP address, which was the EIP address, which is the external access machine IP address, this is translated to the subnet IP address, which is 10.0.10.5, for example, or 6. This is where I'm going to send the traffic to. So that's where the routing table comes into play. They route the traffic based on the mapping of the IP addresses that is kept within the routing table. Okay. What is an internet gateway? Again, internet gateway is a horizontally scaled, redundant, high availability VPC component. It allows communication between instances and internet. Any traffic that comes in or needs to leave the EC2 instance within the EC2 environment, you need to have an internet gateway right here. So this is an important component, because what it does is basically it says, okay, do I have rules and regulation that I can send out the traffic, or I can let the traffic in? So internet gateway is a key component that basically does that job whenever its traffic is coming in from outside, or whenever the traffic wants to leave the subnet or the VPC, internet gateway comes in. Internet gateway are horizontally, meaning you can scale horizontally, and if one goes down, the other can pick up. It allows communication between instances and internet. Internet Gateway, IGW, provides a target in VPC route tables for internet route table traffic. So it basically provides a target saying, okay, well, which machine basically I need to access when it's coming from the outside or when the traffic is coming in. It always it talks to the routing table in order to help the routing table to translate which machine needs to be accessed if some traffic is coming in from the outside, from the internet, or when the traffic is coming out. Perform a network address translation for instances that have been assigned public IP addresses, and Internet Gateway translate the reply address to the instance public IP address and maintains one-to-one mapping of instance private IP and public IP. So it's very important to understand that if you don't have an internet gateway, then you won't be able to go out or let the traffic come in to your EC2 instance. So that's a very important and key component when you come to VPC. Okay, so I've already talked about that. Okay. So this is just another example, right? So so this is the internet gateway. You have the routing router. So there's a routing table, right? One other component I've introduced here is they call the ACL, the access control list. So I think I talked about it just a second ago, where if you want to deny a traffic coming in with a specific IP address because you're suspicious of some phishing, some SQL injection, some hacking, what you do is you put that address range in that ACL. I had an experience where a few months ago we were having a traffic that was coming in from Russia with the RU, right, a domain, and it was trying to access our machine. So we had to actually define with an ACL any traffic coming from that. We translated the IP address, we traceroute that, and we put that address range in our ACL. So anything coming from that address range would actually be blocked. So ACL would work there where you want to define any IP address that doesn't need to be passed through to be allowed into your internet into your VPC or access any of your asset on AWS. So we defined that in ACL, and we were able to actually successfully thwart that and then stop that traffic coming in. So that's a key concept that is defined in this. The other thing is the security group. So again, like I said earlier, security group allows you to add a rule where you say, okay, what are the ports, what are the IP address range that are allowed for what protocols. It could be an IP address of your machine that needs to do an SSH. So if you want to allow a specific IP address machine to have access to a specific EC2 instance, and the protocol that is allowed is SSH, then you would actually define that in SG, the security group, right? If you don't allow that, then any machine who's just trying to do an SSH or ping, if that IP address is not defined in that SG or security group, that machine will not be allowed. And I will show you that how you define that. Okay, these are the labs. When I was doing the other, online training session, I would ask people, and I would ask you guys as well if you have time, because I'm kind of covering at a high level. This is a webinar just to give you an introduction of these basic concepts, starting from the cloud and into the storage, into the accessibility IAM, and now into the networking. But I think the onus is on you guys, whoever are participating in today's webinar, is maybe take this as a homework assignment and actually try it on your own. So I did this for one of my session when I was doing a workshop, where I would ask them to create a subnet, a private subnet, a public subnet, launch instances on each subnet, attach internet gateway to access the internet, access instance on private subnet, create a security group, allow certain ping, DB, SSH, HTTP, HTTPS protocols within the SG group, attach SG to this instance, attach to the private subnet, net instance, which is basically a network gateway instance, allow that so that you can access the gateway as well. Okay, so having said that, let me just pause here for a second, and maybe what I can do is take you guys on a workshop, right, and see if I can show you guys some of these key components associated with this. Shane, can you confirm you can see my AWS console?
Yes.
Thank you.
Yes, I can.
All right, so I am in AWS console. I'm gonna go into, let's go to Central. Here, you will go under the area of networking and content delivery. Here you can see there's a VPC. You click on VPC. It takes you here, right? So I think I have 5 VPCs already created. Let's see. Here it is, right? So these were all my AWS clouds that I did. So if I click on, for example, this one, you can see there's a routing table defined. This is the VPC ID. You would need this ID if you are, remember in the earlier part of this session, I talked about different ways of accessing it. For example, using the SDKs, right, software development kit, or using the CLI, command line interface. So when you're actually accessing through the CLI or maybe through the code, you would need this VPC ID if you want to do something with that VPC. So this is where you would need it. The state available. This is the IP address range, right? So when I was creating the VPC, I give then IP address range of /16, meaning 65,000 IP address range. It's not using IP6 protocol. Network ACL, again, this comes by default, where you can define what needs to be blocked. DHCP is options, again, for the host configuration. This is owned by, you can ignore all that stuff. Routing table, again, this is the default routing table that gets associated with it. Okay, let me just go ahead and create a VPC so you guys can see it. Okay, I'm gonna give it a tag, IP. Okay, so now this is where you would actually define the IP address range, right? So if I define 16, so basically it is giving me the range of IP4 addresses for your VPC insider block, for example, 10.0024. Block size must be between 16 and 28, right? So this is the range that you can define. So I'm defining at 16. No IP6 required. Tenancies default, you can leave all of that stuff as is. Create. Oh, I have already created, yes. Now this is a good test because 1, 2, 3, 4, 5. Remember I talked about 5 IPCs that can be created in one region. So let me just go ahead and delete this one. Everything else below this VPC will be deleted. Okay, hopefully now I should be able to create that. So webinar VPC. 10.0.0.0.16 default create. There we go. So this VPC is created. Let's go here. And here's my VPC. Okay, now if I go in here, notice that there's a routing table by default got created, then the main network ACL list got created, right? So here it is. And let's look at the Cidr IP address. This is 10.0.0.0.16. That is by default, no IP6 because I don't need that. Let's go back here and let's see what other actions. So if you want to edit the IP address range, you can add more IP address range. Okay, let's look at the ACL. So this is the ACL. So here you can go ahead and define your inbound rules. Right, so this is allow or deny, right? So you can define, okay, for example, this is the IP address that's not going to be coming in. You can define this by creating edit inbound. You define the rule, add a rule. Okay, so you can say 110, whatever, custom rule. So all traffic, UDP, datagram protocol, SSH. So if you're blocking something, then you can say, okay, deny, I'm going to deny all of this. And then you define the IP address, right? So you can say any IP address range from, 10.0.0.1 / 16, anything that is in between that range, I want to block it, right? Or you can specify a specific IP address and say, okay, this IP address is not allowed. So you can define that in this area. Okay, let me just delete this. So this is your inbound. Outbound, again, what traffic is allowed, you can go ahead and define that as well. Subnet association, we haven't covered that. I'll show you in a second how to create your subnets. Let's go back. And okay, let's go back to the VPC. Here's my VPC. Okay, and now let's look at the routing table, what we got in the routing table. So the routing table is, again, it has certain rules, right? So this is associated with this VPC, as you can see. Route every single traffic, 10.0.0.16, all of the range coming in is routed through this routing table, and it is active. Subnet association. Now, again, we haven't created the subnets yet, but if you create the subnets, then you can associate the subnets with this routing table, right? And let's see, you can edit subnet association. Okay, let's jump to these subnets for a second. So these are these subnets I've already created before. Now let's go ahead and create a new subnet. Okay. You can type in any tag, right? And it always try to create a tag because it allows you to associate the asset that you are creating with a specific environment, for example, dev environment, QA, or HR, or the groups. So this way you can find out the billing, right, for each department or each environment. It becomes very handy. The VPC, so you're creating a subnet. If you remember in the diagram I was showing you earlier, within a VPC you have created, I've created separate subnet 1 and 2. Now I'm creating a subnet. So if I go and create, assign the VPC, so this is the VPC we just created, which is the webinar VPC. Now availability zone, no preference. If you want to leave that as default, that's fine. This is the range. Don't want to pick the oh, sorry. So 10.0.0. There you go. So I just created that VPC subnet within that VPC. So here it is. Okay, so this is a subnet that I created inside of the VPC, and the routing table is associated with the same routing table, which is part of the VPC. Okay, now if I go to my routing table, you can see this subnet is associated with this. Okay. Modify auto assign and edit network XO routing table association. So this is the routing ID, and again, if you need to access the subnet from your AWS, as from your CLI or from your SDK, then you would actually need this routing table ID. So what exactly did we do so far, right? So let me just jump over here and go back here. So all I did was basically created this VPC right here, and I created a subnet, right? And this routing table was already part of it. It was already created for us, so we don't really have to do this. The Internet Gateway default was created and associated with this. We just created this, and we provided this IP address range, okay? So this is what we have done so far, okay? Now, what we can do is cancel this. Now, if you want to launch that EC2 instance within this VPC, what do you need to do is basically you go back, go to the EC2 compute section. You see running instances. Okay. We can launch an instance, for example, create launch instance, free tier, select general purpose. Now, when you come to this screen, right? So this is the number of instances, only one. We are creating one. Network. Now here you can see by default I've selected this webinar, right? There are multiple VPC that are available here, but I'm selecting the one which was webinar VPC, which we just created, right? The subnet. So this was the subnet we created, right? So this was the webinar subnet we created. Now again, you could create a private or versus public subnets, right? And define that over here. So if I had created 2 subnets, then I would see 2 subnets over here, which means, again, let me just refer back to this PowerPoint. So if you had created these 2 separate subnet 1 and 2 with a different IP address range, then you would actually see those 2 subnets available here, and you can pick the one that you want to. Why do you need this? Again, If you remember, I talked about the private subnet where you can define your database instances, right? So you can say, okay, my database would be actually behind this private subnet versus my web server would be behind that my public subnet. So when you are launching this EC2 instance, if this is your web server, you would actually put it behind your public subnet because everybody is coming in and accessing that public subnet using your www whatever. But if you're accessing your database, which your application server needs to talk to, then you would most likely and highly recommend it. Within the architecture, you have to think about it, but you would put your database behind that private subnet. Hopefully that would make sense what I'm saying, right? Using auto-assigned public IP, so what happens is if you continuously start creating IP EC2 instance within a subnet, the range that you give in setting up that VPC and then subnet, you would actually, the automatic assignment of the IP address will be done by AWS, picking up the IP range from the subnet IP Cidr block range that you have defined. So what I mean by that is if you have defined, let's say here 10.0.0.24, right? So you would have 32 minus 24, so 2 to the power 8, 256, right? So you would have 256 IP address range. So whenever you are assigning a new EC2 instance to this subnet 1, the IP address will be 10.0.0.1. blah, 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 all the ways up to 256 machines that you can launch over here. Now, if you start assigning machines over here, then it would be 10.0.1.0, and then of course it would start, incrementing the numbers in that range, right? So depending on which subnet you have picked when you're launching your EC2 instance, number one, and number two is that how many IP addresses are available with that IP address range Cidr block that you have defined, right? So this would be all determined on your setup when you're doing the subnet and VPC. So you can see there are only 251 IP address range available, right? Because of the way that VPC was set up. Placement group, everything else, you can probably leave it. This was the main thing that I want to show you guys. Storage, again, by default comes with 8 gigabyte. Configure security group. Now, security group, create a new security group, right? So this is where I was talking about you can define your IP addresses and stuff like that. For now, let's use the selected default security group, and I'll show you in a second how to create that security group. Choose an existing demo key, for example, acknowledge, and launch an instance. Now, what's happening obviously is just trying to launch that instance within that VPC, within that subnet. So this is gonna go ahead and start to spin that off, right? So while it's doing that, why don't we jump over to the security groups, right? So security groups are, again, where you are defining the rules and IP address and the protocols, right? So if I go click on create a security group, so let me create a webinar. And you can have a security group where you say, okay, the SSH protocol would be allowed in that security group. This security group would be for database, IP database accessibility. So you can have different security groups defined based on that. And which VPC you are creating the security group in. And this would be webinar VPC that we just created. Shane, just checking, you can still see my Amazon console, correct? Okay, perfect.
I can. That's correct.
Perfect. So this is the security group I'm defining within this VPC, right? Let me just go ahead and create first, and then I'll come back. Okay, so here's a security group name, owner, ID, description, and the VPC, which is associated with this. Inbound rule. Now, this is where you would start defining who can access or who can come into your EC2 instance, right? So I can say added inbound rule, add rule, custom IP. These are all the protocols that are available, right? All traffic, all TCP, UDP, all traffic, SSH, SMTP, ping, right? So you can define all of that stuff here, right? So for example, if I say all traffic and protocol is all, of course, and then if I would have changed this, then you would actually define protocol and port range. But since I'm saying all kind of traffic is allowed here, right? Which is not a good practice. Obviously, you want to limit what can comes in. Now, the source IP is where you are actually the request is generated or originated from. So whether you want to say, okay, this IP address, a specific IP address, or range, right? So I'm going to say, go ahead and say my IP address, right? Which means my local machine, 76, 71, 29, 193, 32. 32 is because, remember, 2 to the power 32 minus 32 is 0. So it's the one specific IP address which is being allowed to access all kinds of traffic on that security group, right? And save. There we go. Okay. So this is the rule that I have defined here. Okay. Now I'm going to go ahead and put in EC2 instance under that security group. Okay. So let's see, we have created, we can go ahead and create one more instance. Let's say free tier, select. Okay. Next. Okay, I'm going to leave this here. I'm going to leave this as is. Previously, one second. Okay, so that's fine. Oops, sorry. Okay. Now create a security group or select an existing. So I'm going to select an existing security group, and I'm going to select my webinar security group because I have allowed a VPC access to it, this IP address available to it, right? So here we go. Launch. I think that should do it. And I'm going to use a demo key as my AP key. Okay. And let's see. This is the IP address. So now I have created this EC2 instance associated with this VPC with that EC2 instance and assign a security group with it. And if you want to see the rules, you can go ahead and review the rules by clicking on View Inbound Rules, View Outbound Rules, and I would actually tell you everything is allowed from this machine inbound. This is the IP address that was actually my IP address that I have allowed. So all ports, all protocol, this IP address allowed to actually access this machine. Let's see. I just wanted to check this. Once it's done, then I want to see if I can access this. Okay. Well, it's loading and then initializing. Is there any questions, Shane, on the chat that I can answer?
No, not yet.
Okay. So guys, I'm going to start summarizing. So what we have covered so far today is basically networking aspects, the key components of networking, VPC. VPC is virtual private cloud. So basically you're creating an environment where you are preparing it so that you can start inserting your security groups there, your access control list, the internet gateway, and then EC2 instance inside of it. This allows you to expose your private versus public, right? Subnets, outside world. So normally you would actually put all of your databases and all of the services and machines that are not needed to be exposed outside within that private subnet. Anything that needs to be exposed outside, you would actually put that as a public subnet. So we talked about the private and public subnets. Security groups, again, allows you to create rules that would allow the machines to be either going out or coming in. So based on the source, for example, I have defined my source IP address that can access a specific machine within a public subnet. ACL, usually you would put a rule for denial, meaning that, okay, anything that is coming with this address range, I want to make sure it is gets blocked and not given access to it. internet gateway and routing table, so they work together. If traffic is coming in with a specific IP address, which is not local IP address or subnet masks, then the internet gateway basically translate that IP address into the local, and the local IP address is passed on to the routing table, which basically knows which subnet it needs to go in and routes the traffic to that specific machine EC2, which is hosted inside of the VPC. So I think it's done running. Okay, so let me see if quickly, if we have a little time. Oh, this one may not probably have it. Okay. Private, okay. Networking change. Okay, here it is. Okay, yeah, that's